All right, let's move on to the next activity, 9.2. What we'd like to be able to do is figure out how to move between coupon bonds and spot rates. It's for zero coupon bonds, it's pretty simple, right? The interest rate that gets you from the purchase price to the final redemption amount at maturity is your spot rate. But if we have spot rates, how do we value a coupon bond or price a coupon bond? If we have information from coupon bonds, can we extract the yield rate, the yield curve from the coupon bonds? That's what we're going to look at in this video. There's also something else, not just in this video, but in the next several videos in this activity. There's also something else called the at-par yield rate, which is kind of like a way of roughly interpreting. You can roughly interpret it as kind of like an average for the yield curve. But we'll get to that in the last video for this activity. This activity is probably the most, I would say it's the most complex and difficult of this entire chapter. You can disagree. If you think another one's more difficult, it doesn't really mean anything. It's just my opinion. But because of that, there'll probably be more videos for this activity than any of the others. All right, so let's get started. So let's look at an example. So basically what you do is you price each payment, you value each payment using an appropriate spot rate. You might recall that this was on the last exam without using the word spot rates. And almost all of you, maybe even all of you, I don't remember, actually use something called forward rates instead of spot rates. And that's probably because I didn't describe it terribly well in the problem. But then you all revised it and it was fine. And of course, I thought that was a perfectly reasonable approach, even if it wasn't quite correct. And so that was just like a 9 out of 10, a small nick. Anyhow, so now we're going to actually do that. So let's say we're given the term structure we're staring at, right? The 1 year interest rate spot rate is 15%, the 2 years 10%, the 3 years 5%. So you might notice this is an inverted yield curve. It's always worth kind of making those observations. All right, so now as I noted right here in the problem, these are effective annual rates of interest for zero coupon bonds. Right? Now we've got a newly issued 3-year bond with face amount 100. It's got annual 10% coupons paid once per year, just so that the coupons need to match the term structure. And the first payment's 1 year from now. So basically it's a standard bond, right, with annual coupons. So we want to price this. We'd also like to find what the yield to maturity is. Notice without the term structure, we don't have enough to price the bond. With the term structure, we can price it, and then we can use our calculators to get the yield rate. So let's dive in. So as I noted, the first thing we do is take each payment and find their present value using the yield curve. So 10% with a face value of 100 means that the first payment is 10, second payment is a coupon payment of 10, last payment is the redemption amount of 100 plus the last coupon of 10, so it's 110. So the first coupon of 10 gets discounted at 15%. The second gets discounted at 10%, but over 2 years, because that's what the term structure means. That's what S02 means, is this is an annual rate in effect for 2 years. So we discount that for 2 years. And the 110 gets discounted at 5%, but for 3 years. So we put all that together, we calculate it, and we get 111.98. Hey, it's it looks to me like it's a premium bond. Maybe not. I'm not sure. Well, the price is bigger than the redemption amount. So yeah. Anyhow, with this price, you can use the financial calculator now to figure out. You put in 111.98 for the present value, -10 for the payments, -110 for the future value, 3 for n, and calculate the interest rate. And according to what I wrote here, I got 5.555%, which is why I started to stumble when I said, "Oh, this is a premium bond." because the yield rate's low. Oh, yeah, no, that's consistent. The yield rate's lower than the coupon rate, which means you're beating the market. So, yes, it's a premium bond. Sorry for the stumbles. On we go. So here's a more extended example. So there's a bunch of calculations in this example because what you're asked to do, we start with a 10% bond with face amount 100 that matures in 3 years, and we're also going to go back to semi-annual coupons. And you're asked to find the price with 3 different yield curves. Then you're asked to find the yields to maturity using your calculators for each of those. And then you're asked to do the same examples but using 8% coupons and 12% coupons. So there's a lot of calculations. So for practice, I'm going to recommend that you pause here and attempt all the calculations and then come back and pick up the video. Okay, I hope you paused. I'm not going to go through each calculation because they look identical to what we just did, but I want to point out the results because there is something I noticed, and it raises a question, and I don't have an answer, but I want to point out to you, it's just a good exercise in thinking about what we're talking about here. So, in A sub I, notice this is a normal yield curve. All the spot rates are increasing. And notice these are, by the way, nominal spot rates convertible semi-annually. So if you made some mistakes, that's where you made them, is you probably forgot to divide each of these by 2. Anyhow, so if you made that mistake, I'm going to pause. You can pause again and reattempt at least some of these. But let's move on. We'll take a look at the answers. So with this normal yield curve, we get a price of 104.05. The next yield curve you might notice is inverted. With the inverted yield curve, we get 93.15. So the price of the bond is higher with the normal yield curve than it is with the inverted yield curve. And one is a premium and the other is a discount. Right? Now the last yield curve is flat. Since you have a flat yield curve, you can just actually use 6% as your effective yield rate and just calculate this in your financial calculator and you get 95.08. So with this flat yield curve, we actually have a discount bond. Makes sense because the coupon rate is less than the yield rate. Now, with higher prices comes lower yields. So with the normal yield curve, we got an 8.44% yield on the coupon bond, and that was a premium bond. With the inverted yield curve, we got less than 100 for the price, so a lower price, so a higher yield of 12.82%. Remember, these are quoted as nominal semi-annual. The last one, of course, is 12%. You don't even have to do any work for that because you've got a flat yield curve. So then we're asked to do, so what have we noticed? We've noticed lower prices and higher yields with an inverted yield curve. And that may generally be true. I don't know. That's what I wonder, if there's something to that, right? Do bond yields go up when the economy looks a little more uncertain? I don't know if that's generalizable. But we could also see if there's something related to the coupon rate that impacts that pattern. So we do the same thing with an 8% bond, and now we have a discount bond now, 98.83 with the normal yield curve, whereas with the inverted yield curve, we get 88.32. So that pattern appears to continue, even with a different coupon rate. And of course, with the flat yield curve at 12%, we can just calculate it. We get 90.17. And we do the same thing with a 12% bond. And in this case, the same pattern emerges. 109.28 with a normal yield curve, 98.04 with an inverted yield curve. And by the way, the flat one is nothing to think about because not only is it a flat yield curve, but the coupon and the yield rates match. So it's a par bond. It's priced at par, so its price is 100. All right. So from this exercise, what did I notice? What did I wonder? Well, I noticed that in all cases, the prices of the bond and therefore the yields for the bond, the prices for the bonds are lower with an inverted yield curve than a normal curve, and therefore the yields of the bond are higher for an inverted yield curve than for a normal yield curve. I do not know if that's generalizable. That's something I wonder what do I wonder? I wonder if that's true, generally, if there's something else we can say. I have not investigated that. Finally, the last thing we'll talk about in this video is what can you conclude if you have a flat yield curve? Well, the implied yield rate on the bond is actually equal to the yield curve, the spot rates, because you have a flat yield curve. That means your spot rates are all constant interest rate. And there's actually something about uniqueness of the yield in a bond given the cash flows. And we didn't talk about that back in chapter 7, and because it's not something mathematicians really like, uniqueness and existence and uniqueness. That's really important to mathematicians. But to applied mathematicians, especially those working in industry, you often take existence for granted, and you don't worry too much about uniqueness unless you have multiple possibilities, in which case you use kind of the context to figure out which answer to use. So all of this has been related to pricing bonds using the yield curve. Now we want to go the opposite direction. So in the next video, we're going to talk about something called bootstrapping, where you extract a yield curve from different bonds.